Hello, hello. If you guys can hear me, can you spam the hearts in the chat? If you guys can hear me. Can? Okay, can, good. Okay, we'll just wait a bit for us to join. Sorry, the other link was not working because of, I think got too many people. Are you going to upload this? No, this will not be uploaded. This is a one-time thing. After this, the live will not be uploaded. Okay, we'll start in about 5 minutes. Wait for everybody else to join. And yeah, sorry, the link was not working. Now it's working. Hello. Okay, guys, before we start, just a question for you guys. Okay, tomorrow is your prac, literally tomorrow, right? So from a scale of 1 to 10, how confident are you guys for your prac? From a scale of 1 to 10. Let's say in the chat. Okay, 53350. Okay, can. Okay, no worries, guys. So today we are gonna cover everything to do with your prac. Gonna give you guys a good baseline such that you guys can score as well as you can. Okay, if you're 1 out of 10, I cannot confirm for you that you're gonna become 10 out of 10, but I can confirm for you you at least become like 6 or 7. Okay, you're at least gonna be quite confident in your prac. Prac, I have trouble with significant figure. Okay, later we'll cover that. Okay, so a lot of people are here. Let's just start first. Okay, so who are we? Basically, let me just go through this. Let me just go through this slide deck before we start. I know everybody's rushing, but we're Singapore's first fully online tuition center on a mission to make high quality education accessible to every student. Beyond online lessons, we believe in providing all students with the tools that they need to succeed, and online tuition for those who are ready to level up with us. Okay, so this is like an example for one of our online tuition classes. Okay, but we're giving it for free today because we want everybody to do okay in their prac. Okay? I know a lot of you are feeling scared for your prac. Okay, so we are a team of 8 young tutors who specialize in online classes, and we not too long ago have been through the O-level grind just like you. Okay, so me personally, I'm studying at NUS. I'm 21 years old this year, and all of our tutors are around this range. Okay, so you can think of us as like your older brother or your older sister. Okay, just let me get through this yapping first. After that, we will get into class. Okay, so we made the top universities such as Cambridge, NUS, and LSE. We'll show you how to do the same. 6, 7. Okay. Dojo difference. Okay, this is some of the examples of our notes. Look like this, and it works. 65% of Dojo students score A, actually more than 65%. You can even say is 67%, 67%. Okay, whereas the national A1 average is less than 25%. Okay, so will you take these chances? Okay, a lot of our previous students have taken these chances, and it has worked well for them. Okay, by the way, our regular classes are oversubscribed. Okay, after this, we're going to go straight into class, but our regular classes are oversubscribed. There are no slots left. If you got F9 to B3 for Chem, just listen up first. For the first time ever, we're actually offering Pure Chemistry Lifesaver Bootcamp, okay, with me. Okay, so if you got between F9 to B3 and you are scared, you want to get a better grade, we are offering this for the next 1 month. Okay, so what do you get? You get 4 times intensive bootcamp sessions, full year notes and worksheets, full year cheat sheets and summaries, 4-week step-by-step study plan, 1-to-1 study strategy call, and 24/7 WhatsApp support. Okay, so all of this stuff, this is your bootcamp session. So for example, session 1, we're going to go through structure and bonding. Session 2, we're going to go through reaction and calculations. Session 3, we're going to go through organic. And lastly, we're going to go through energetics. Okay, so if you guys want to join this, if you guys are interested in this, it's on Sundays 4 to 6 for the next 4 Sundays. And then, yeah, we're going to make sure that you get as good of a grade as you can get within these 4 weeks. Okay, on top of this, we also got a bonus session right before your paper 1, right before your MCQs. We're going to go through MCQ mastery. Woo, cool name. Right, so right before your papers on Thursday, we're going to go through this, and this is free of charge. The last session is free of charge. Okay, so limited slots. This is limited to only 8 students. Okay, so honestly, right, I can only give enough attention and personalized guidance to only up to 8 students. Okay, so the first 8 people who want to sign up, let me know, and then we will talk about it. Okay, so to guarantee results, only 8 students will be accepted. First come, first serve. Okay, so if you're interested, last year our average grade improvement for our normal students was a +4 grade jump. This is a legit average. Okay, so for example, if you got C5, the average was to go to A1. If you got D7, the average was to go to B3. Okay, So if you're interested, just scan this link and it basically just sends you to WhatsApp and I'll text you about it. Okay, so I'll leave this on the screen for like 20 seconds and then we'll move on to the actual crash course. Okay, if you guys are interested, again, so just scan this link first, and it's on the right side also if you want. Okay, I'll reply all of you guys later. Okay, if not, give me 1 second. I'm gonna, because a lot of you guys joined the WhatsApp group a bit late, so I'll forward this to the chat again. Give me 1 second. Okay, so for those who just joined the WhatsApp chat, please look at your worksheet that I just sent. Okay, I'll give you guys a few seconds to take this out. I thought got Google Meet. Okay, yeah. Are these the ads before the movies? Yeah. So if I see 6 right now, I confirm get A2. No, you don't confirm, but last year that was the average. Okay, let's start. Okay, today what we're going to go through very, very quickly is your planning, your QA, and then lastly your titration. Okay, so for planning, a few very, very important things. Okay, please don't call me. For planning, a few very, very important things that I want to go through is the 5 key marking points. Okay, so there's 5 exact things that they're looking for when they're marking your planning, no matter what topics come out. Okay, so these ones, as long as we know what they're looking for, right, we can score 6 out of 6, we can score 5 out of 5 for our planning. Okay, so next is the possible topics to come out that I personally am predicting. Okay, next for your QA, how to phrase your observations to get full marks. Okay, and how to never miss an observation and what to think about so that you can score for your observations. Okay, how are you so handsome? Thanks. Okay, first of all, before we go through anything to do with planning, I want to go through the apparatus. Okay, so your apparatus, this one, honestly, I got nothing to say. I just want to put this on the screen and put it in the worksheet so you guys can memorize. Okay, so these ones you just need to know. Depending on what you're measuring, you have to use different apparatus. Okay, legit nothing to learn, it's just memory work. Next, this is the important part. Okay, so all 837 people watching now, please listen up. Okay, the marking scheme for planning is always the same. Okay, so there are 5 things, right, that markers are looking for when you are marking your practical. Okay, legit only 5 things. It can be memorized as ACIDS. ACIDS. Okay, so A is our aim. Right, what's our aim of the experiment? What's our hypothesis? C is our constant variable. What variable should be kept at the same to make the experiment a fair test? I is our independent variable. D is our dependent. So these two are different. Independent means what variable will be changed to achieve and prove the aim of the experiment. For D, what variable are you going to measure? Okay, dependent means you're going to measure this one. This one is going to change. Okay, and how does the analysis of this variable prove your hypothesis? Okay, and then lastly, S means is your conclusion. So based on your findings, what conclusion can you make for this experiment? Okay, for example, if you're using graph, what does the gradient represent? Okay, so everyone, please remember these are your 5 marking points. Okay, so you might be asking me, right, Cher, this is probably very, very similar to what my teacher taught me in school, right? Why is this important? Okay, this is important, right? Because under your general tips, you have a lot of, there's a lot of things that I want to talk about. Okay, so for your, when I was looking through my own students' prelim papers, okay, these are the standard stuff that always get wrong. Even though you look at the planning question, then after that you're like, oh, I confirm know what I'm doing. Then suddenly I get 2 out of 6, okay? Then what the hell, right? So general tips, right, is firstly, you want to write your procedures starting with a verb. Okay, a lot of times, you guys never write with a verb. The verbs are like collect, heat, measure. So collect this, heat this specific amount, measure this specific amount. Okay, let me change color so it's not so boring. Okay, the next tip is state the exact apparatus and measuring instruments you will use. Too much is better than too little. What that means is that if you literally write the exact apparatus and exact measuring instruments, right, you'll never lose marks. You only gain marks. So just be damn like super duper anal about it and just be very tedious and write every single apparatus and every single measuring instrument you use. Okay, if the question is to do with calculation, which I'll show you guys later, you must use unknown variables for the physical quantities measured. For example, if you're going to measure the mass of a dry residue, you want to call it X, for example. Then if you want to measure the, let's say, volume of gas produced, then you want to call it Y. Okay, so why is this important? Why is this important? No pun intended. But why is this important is because if you have these values and you want to put it in another calculation, you can say, for example, number of moles of gas is Y divided by 24. Okay, so these formulas and stuff is very, very important for you to score full marks. Units, yeah, correct, units. So it should be X grams and Y cm cube. Correct. Okay, so very, very important to make sure that when you literally measure anything, put a star next to this one. When you literally measure anything, you want to give it some form of name. So X or Y. Okay, in this case, we'll talk more about it later, whether you should use cm cube or dm cube. So later I'll talk more about that. Okay, then fourth point, write down the calculations like I said over here. Number of moles of carbon dioxide will be Y over 24. So you can use these unknown variables to go and calculate your stuff. Okay, and then lastly, in your conclusion, so the last point, state how information such as gradient of a graph is able to provide a conclusion. So you must link the evidence to your conclusion to be able to get full marks. Okay, any questions so far? Anybody got any questions? You can type it in the chat. Okay, by the way, for those interested, information. Okay, I know a lot of you guys are interested. Okay, let's move on. These are the types of planning that will most likely come out. Okay, so I've narrowed down to 4. Can remove chromatography. This one is, if it comes out, should be okay. Okay, so types of planning, there's 4. Number 1, mole concept. Number 2, acid and base. Number 3, salt prep. Number 4, QA. Okay, so for this one, for mole concept, generally what's going to come out is either percentage by mass, percentage purity, or finding of concentration. Okay, so today we don't have enough time to go through each one, but what I want to do is give you a general idea of everything so that you can be confident in scoring in whatever thing that comes out. Is the formula the link? No, the formula is not the link. If you have a formula, you must state how the formula proves your conclusion. Can electrolysis come out? Yes, can, but very low chance of coming out. Why no chromatography? Chromatography is very, very simple and it's normally only 4 marks. So I'm just erasing it because it's not to do with today. Like today we have nothing. What about reaction can come out? Okay, again for planning, literally anything can come out, but the stuff that we will learn today, is applicable to anything. Yeah, came out last year, which is why it's a lot lower chance to come out this year. Chromatography. Okay, let's just look at a few examples. Is this for pure chem? Yes, this is specifically for pure chem. Okay, this example is very, very important. Look at question 3. Question 3 says metal carbonates undergo thermal decomposition to produce metal oxides and carbon dioxide. Okay, so the more reactive a metal is, the more difficult it is to decompose its carbonate. Okay, the more reactive a metal is, the more difficult it is to decompose its carbonate. Okay, so this is the key stuff over here to answer this question. Okay, we quickly analyze this question and then I'll let you guys try. So you're required to plan an experiment to determine the order of reactivity between the metals calcium, copper, and zinc by comparing the relative ease of decomposition of their carbonates. Okay, so again, this green part is linked to this green part over here. Okay, so you're provided with everything. Your plan should include a list of quantities that will remain constant, measurements to be taken, and how your results will determine the reactivity of the given metals. Okay, so the first thing I want you guys to do, I want you guys to spend about 2 minutes. I give you guys 2 minutes to try this. Try and write out the acids in this question. Write ACIDS. Okay, so I'll give you guys 2 minutes and try to write this. Okay, while I answer the questions. Is knowing mole concept, acid and base, salts and QA enough for practical? I wouldn't say enough, but literally anything can come out. Yeah, if you want, you guys can put it in the chat, your ACIDS. Okay, 1 more minute and then I'll go through what the answer is. Yeah, last year was chromatography, which is why I erased it, because it's a lot lower chance to come out. Is it a must to draw labeled diagram? No. You can if you want. Can test for amount of CO2 collected per unit time. Yes, that's good. Very good. What chapters must die study? Mole concept, QA, acid base. Okay, so let's look at this again. Your A is your aim. So what's your aim? Your aim is to figure out which one is figure out the reactivity of the metals relative to each other. Okay, so how do we figure this out? Is about the difficulty to decompose the carbonate. Okay, so that's your aim. You're trying to find what's the how hard it is to decompose this carbonate versus that carbonate versus the next carbonate. Okay, I realize you guys cannot see this. Give me 1 sec. Yeah. Okay, then for C, this is your constant variable. This one will be the particle size of the carbonate. This one can also be the amount of heat provided to each carbonate. Okay, so again, the constant variables, the whole point of constant variables is to make the experiments fair. Okay, for your independent variable, which is the one that you're going to vary, is the type of carbonate. For the dependent variable, this one you can either choose, there's 2 ways to approach this question. The whole point of carbonate, right, is that it decomposes, for example, like this, the metal carbonate, let's say MO2 decomposes to give, MCO3. Let's say MCO3 decomposes to give MO plus CO2. Okay, so carbon dioxide is going to be produced. So by measuring the volume of carbon dioxide, we can actually figure out which one is easiest or fastest to decompose. So you can either take it such that you do the amount of, the volume of CO2 per unit time, or you can do time taken to reach specific volume. Okay, so please copy this down first. Okay, 1 second guys, please copy this down first. I need to fix something. Okay, wait, never mind, I'll just hold it first. Okay, so it's the time taken. Can you say time taken for lime water to have PPT? No, cannot. Okay, don't call me Ang, I'm young. Okay, so for D is your dependent variable, right? This will either be the volume of CO2 per unit time slash the time taken to reach specific volume. Okay, lastly, your conclusion will be the one who is easiest to decompose will be the least reactive. The one that is the most difficult to decompose will be the most reactive. Okay, so in this case, less CO2 per unit time equals to hardest decompose equals to most reactive. Can just measure mass loss. In this case, you cannot measure mass loss, no. Because mass loss doesn't, in this case, the masses lost for each one is going to vary, not because of the ease of decomposition, but because of their mass per mole. Right, because they all got different MR, so it's not constant. So the only way to be constant is to use volume of CO2. Different elements have different MR. Yes, correct. Okay, because they're different compounds made of different elements, they will have different MR. So you cannot use mass loss. Can I write until the piston in the gas syringe falls out? No, cannot. Okay, so what I'm going to do now, this one is 5 marks. For your planning, in total, you should take maximum 10 minutes, right? And for the writing part, meaning literally the writing the steps, you should take about 5 to 7 minutes. Okay, so what I'm going to do is I'm going to give you guys 5 minutes to try this one. Okay, so everybody please take 5 minutes. You can type it out if you want. You can write it out if you want, up to you. Let's try this. Okay, 5 minutes. So what are you keeping constant? Mass. Not necessarily you're keeping constant the particle size of the carbonate, as well as the amount of heat you provide. What's the recommended specific volume of gas? That one, it depends on the question, but you should keep it realistic, right? So not like 1000 dm cube, right? About 25 cm cube is okay. Can show the question? Okay, can. I'll show the question on the screen. So what I'm going to do is 5 minutes until 5 p.m. You guys try the question and then I'll go through. Why would less CO2 produced be hardest to decompose? Wouldn't it be more CO2? No, because if it's hard to decompose, then it'll take longer to decompose. Can keep the constant time taken for CO2 to produce. Can. What's acid S again? S is so what? So it's like your conclusion. Then if you have a different mass of each carbonate, wouldn't the different volume of CO2 be produced? No. Hi, do you think organic chem will be plastered for planning? That one, if you use the same mass of metal carbonate at the start, why can't I measure mass of solids left over and the one with the most solid left over is most reactive? In this case, you can't do that because the amount of mass loss will be different for each one, because the MR of each one will be different. What's particle size? Okay, particle size in this case, if you remember your rate of reaction, right? One of your factors is surface area. Right, so if each different carbonate has different surface area, then it will affect the results. Yo, so why do you think organic chem won't be tested? It's not that it won't be tested, is that anything can come out. So like honestly, yeah, anything can come out. So I cannot tell you that. Okay, but these are the ones that I'm personally predicting that will come out. Can energetics be tested? Again, anything can be tested. This is about the skills. Okay, 1 more minute, I'm gonna go through. Can we have a set number of moles of each carbonate, like 0.2 moles, and then measure mass loss due to CO2? Again, cannot, because the MR of each of the carbonates is different. Do we have to crush it first, or can we assume it's already in powdered form? Either way can lah. Okay, let's look. Okay, I'm going to scroll down to the answer keys, not to waste your guys' time, so we can just look at the answer key. Okay, I'm not going to write it down, it takes a lot of time. Okay, question 3. Okay, there's the two methods that are outlined over here. Again, it's either you measure the volume of CO2 produced in a specific fixed time, or you measure the time taken to produce a fixed volume of CO2. Okay, so for method 1, this one is using an electronic balance, measure 5 grams of calcium carbonate and transfer it to a boiling tube. Okay, so we're starting with calcium carbonate. Okay, then for 2, attach the boiling tube to a gas syringe. For 3, heat the contents using a Bunsen flame. Okay, then you collect and measure the volume of carbon dioxide gas produced over 1 minute of strong heating. Okay, and then record the volume of gas collected. So over here, very important, I think a lot of you guys will miss out this exact phrase over here. Okay, because there's so many of you guys, I cannot read your ones individually. But over here, please note that you need to say that you're recording the volume of gas collected. Okay, then step 5 is repeat steps 1 to 4 using copper 2 carbonate and zinc carbonate. Okay, over here you use your precaution. Particle size of the metal carbonate is used, as well as the strength of the Bunsen flame. Both of these should be kept constant. So again, this is your C, your constant variable. And then lastly, the metal whose carbonate produces the largest volume of carbon dioxide in 1 minute is the least reactive. Okay, so again, the more reactive metal will be harder to decompose. Okay, so on the other hand, less reactive equals to easier to decompose. I have a question. When we attach a bung or a tube to a boiling tube while it's heating, I thought it would explode. In this case, if you just attach a gas syringe, it would not explode. How do you know whether you should write strong heating or weak heating? In this case, it doesn't matter whether it's strong or weak. It just needs to be a constant level of heating, right? We want to keep the heating constant. What if I say record every 10 seconds and plot graph? That one is not necessary because you don't need to know what the gradient is, right? The only reason why you will plot a graph is when you need to know the gradient. In this case, the gradient is not necessarily. The sample answer only contains process. Where do we list aim and variables? Okay, let me clarify. The acids ACIDS thing is not, you're not meant to write it in the actual answer. This is just a framework for you to understand what's happening, and then you can actually write your practical answer off of that. your planning answer. Can we use acid or no? Because they mentioned about decomposition. No, you cannot use acid. What's the gradient for? Yeah, the gradient is not for anything. That's why. In this case, the gradient is not necessary. Okay, let me show this again. Can we list out the constant variables? Can. Then what's needed for the actual answer? Just your procedure, as well as putting in the constant variable, the independent variable of that. Okay, so here the volume of carbon dioxide gas is your independent variable. Is your dependent variable. Then the different types is your independent variable. How will measuring volume per unit time link to the reactivity? Again, your metal carbonate decomposes into a metal oxide and carbon dioxide. Okay, so the amount of this carbon dioxide that is formed per unit time will show you that is the most reactive. Most reactive equals most CO2 formed. Why cannot use acid? You cannot use acid because this is about decomposition. It's not about acid plus carbonate. Okay, if you guys read through method 2, method 2 is almost exactly the same. It's just the opposite way. In this case, you're measuring the time taken to reach a specific amount volume of carbon dioxide. Okay, the other way around is that you have a specific time taken and then how much carbon dioxide. So everything else is exactly the same. You see the dependent variables, the dependent variable is the only thing that changed. Every other variable is the same. Okay, so the S part here, so your conclusion is that the metal whose carbonate takes the shortest time to produce, 10 cm3, is the least reactive. Why cannot use time taken for white precipitate to appear in lime water? In this case, actually, that one is not wrong. You just need to write it properly. Okay, so Anna, if you want, you can send me your answer if you want me to check. Okay, I'll try to reply you. Okay, so that's it for this question. If any other questions, please let me know. Generally, the idea here again is that you're using your ACIDS ACIDS framework so that you can get a good answer. Okay, so if you're going to draw a diagram, the diagram should be very, very simple. It should have your table, it should have your conical flask, it should have a gas syringe. That's it. Then you just need to label. Oh, wait, actually, you should have your heater also, sorry. You should have your Bunsen burner. Why you say particle size constant? Can you scroll up, use method 1? It's in your worksheet. Okay, that one I won't show for too long because it's just in your worksheet. If we were to draw this, which part should we draw? Use your gas syringe, use a conical flask or a test tube, and then use a Bunsen burner for the heat. Will we score points if we draw? Not necessarily. Okay, you can draw, you can don't draw, you get the same number of points as long as you get same number of marks as long as you get it correct. If no time, should I just skip planning? No. Is it possible to add acid into conical flask instead? Okay, everyone please listen up. This one I want you guys to be very, very clear. If the question gives you a certain piece of information, planning question will never anyhow give you random questions. Okay, they'll never, random information, right? They won't just write this, the more reactive the metal it is, blah, blah, blah. And they won't tell you that it decomposes to produce metal oxide and carbon dioxide. They wouldn't just tell you that for fun. So you need to use the information in the question to answer. Can Mr. Huang, can you do this later? I have tuition now. I'm sorry, man. Metal carbonates are the independent variable. Correct. Okay. Next, let's move on to the next one that I want to cover. Okay, so very, very quick, let's move on to this acid and base. Can any questions, just ask it in the WhatsApp chat later. I'll reply to all of you guys over time. Okay, so agricultural limes are a mixture of calcium carbonate and calcium oxide. So farmers use agricultural limes on fields to neutralize acidity. Okay, so again, when you're reading this question, you must remember that they won't just anyhow give you the information for no reason. Okay, plan an investigation to figure out which of the two agricultural limes will neutralize more acid, right? Will Q or R neutralize more acid? So you're trying to figure out which one is stronger. You're provided with common apparatus and chemicals. You should include the measurements. Okay, so again, I'll give you guys 2 minutes. Please try to write out your acids. What is your acids in this case? I'll zoom out so you guys can do. Okay, 2 minutes. Yeah, I'm not posting the live. So are you sending the answers in the WhatsApp group? Yes, I'll send the annotated copy in the WhatsApp group later. Yeah, zebra's getting cooked. Can I use titration? This is not titration, guys. Please be careful. This is not titration. Why? Because the calcium carbonate and calcium oxide are both solids. Titration can only be done between two solutions. But titration is for two equal. Yeah, correct. Exactly. So you can only use titration if you specifically tell them that you're going to dissolve it first. Is it write acids, then write the procedure? Yes. Okay, so 2 minutes is up. Let's go through what are the acids framework. Okay, so your A here, A is your aim. So what is your aim? Your aim is to figure out which one can neutralize more acid. Neutralize more acid. Okay. Then for your C, your constant variable, you want to make sure that the acid used in both experiments is the same. Okay, then for your independent variable, you want to make sure that you are changing between Q and R. For your dependent variable, you should measure for the volume of acid used. Okay, so again, which one can neutralize more acid, right? So we need to measure how much acid is used. And then your conclusion depends on which way you do it. Loki's curious, should I still text you? Yeah, just text me, then we can talk, don't worry. Yeah, Zebra, don't listen to haters. Zebra, you're him. Yeah, Dino, you can text me if you want. I'll reply to everybody later. Okay, so let's look at the answer key. Wait, actually, sorry, I'll give you guys headache. I will copy paste this. Okay, so this is your acids at the bottom left. I'll leave it here. Here for question 4, let's look at the two different methods. Okay, using a measuring cylinder, add 50 cm cube of dilute nitric acid of 1.0 mole per dm cube and place it in a beaker. Okay, this one I'll speed through because I want to get through to the rest of the stuff. Okay, 2, use a pH meter or add metal orange. So metal orange will be your indicator in this case. Okay, using an electronic balance, add 1 gram of lime Q until the pH is 7. Okay, so the idea here, right, is what they're doing is you're going to keep adding you're going to add your Q or your R until you neutralize it. Okay, and then you note down what's the mass of lime Q added, and then repeat the experiment with lime R. So whichever lime is required in smaller mass can neutralize more acid. Okay, the other approach you can do is the other way around. So you can neutralize it and after that measure the amount of volume needed to neutralize, to be neutralized. Okay, so again, the idea here is that your pH is from 1 to 14, right? Where 7 is your neutral. Let's say we have Q and R over here. If Q is more basic, it would require more acid to become neutral. Right, so this is your pH scale. The one who requires more acid to become neutral or to become neutralized is the one that can neutralize more acid. So again, these are your two approaches. So either you take the amount of mass needed to neutralize a set amount of acid, or you take the amount of acid that is needed to neutralize your Q or your R. Please show the acids for this question. Okay, it's on the left side. So Q and R are alkali. Yes, in the question they did state that they are basic. Since the lime contains carbonate, can I say measure the amount of CO2 produced? No, cannot. That doesn't show anything about the basicity. Is it important to know different indicators? Honestly, if you didn't get above 30 out of 40 for your prelims, the prep, don't waste your time doing that. Can just directly use universal indicator? No, cannot. Can you repeat about the acid? Okay, basically the idea here is you're trying to figure out whether Q or R is more basic. Right, so if, let's say, for example, if Q was more basic, maybe it took 50 cm cube of the acid to neutralize it. If R is less basic, it would take, like, let's say 25 cm cube. So the idea here, right, is that you're trying to figure out which one is more basic. Wait, can you use any type of acid? Yeah, can use any type of acid for this case. Your acids, the constant is acid, and the D is, oh yeah, correct. So this one, to just to be more clear, this one should be your type of acid. So in both experiments, if let's say the first experiment I use HCl, the next experiment I should use HCl also. Are these type of questions similar to the O-level? These are real prelim questions. Why cannot use universal indicator? Okay, the reason why you cannot use universal indicator is because in this specific case, right? In this specific case, there is, again, calcium carbonate and calcium oxide in the mixture. So these are both solids. For universal indicator, you can only use it when it's aqueous. And also it's less accurate. So that's that's not a good answer. Is pH meter an apparatus in the lab? Yes. Must you give specific indicator, or can I just say indicator? If you're going to use indicator, you must give a specific one. Yeah, it's a common apparatus. What indicators do I need to know is under your titration that we'll go through later. Okay. Okay, again, there's a lot of questions. I just want to get through everything so that you guys get a full understanding, full foundation to score tomorrow. Okay, let's move on to QA. This is the part that a lot of you guys will lose marks. Okay, honestly, your planning is 4 to 6 marks only. Okay, your QA can go up to 10 marks of your paper. Okay, so QA is actually a lot more important. So let's talk a bit about QA. Okay, a lot of times I notice that when you guys do your prelim QA, whatever other QA practical, you guys go in and then you don't even know what you do. You just react to what's happening in the exam. Okay, but so you should actually be thinking a lot more than you guys are. So what should I be thinking about? Before you test, note whether the test in the first place, is it a cation test, is it an anion test, or is it neither of the two? Okay, so for example, if you look at the right side, so question A, transfer the solid to a test tube, heat the sample strongly until no changes are seen. Is this an anion or a cation test? This is actually neither an anion nor a cation test. Okay, for C, this one you add sodium hydroxide until no further change. This is your cation test. Okay, how do I know it's a cation test? It's because you're adding sodium hydroxide. Okay, and then lastly, for anion test, you just need to notice whether it's an anion test or not. Just check your cheat sheet whether the test is an anion test. Okay, so when you look through, before you even write anything, you want to write either neither, cation, or anion. Okay, then you will finally know, right, what are you actually supposed to look out for, right? Because if you don't know what type of test it is, you also don't know what kind of observations you're looking for. Could also be an oxidizing agent or reducing agent test, correct? Yeah, but that would be classified under neither. Okay, so when you're recording your observations, these are just some tips. So similar to your planning, these are the tips that I want all you guys to listen to. Okay, record your observations in pen as you guys are conducting the test. This will ensure that important observations are not left out. Okay, what do I mean? As you're literally doing it, you should be writing at the exact same time. Okay, this one is the most important. Please put 3 stars next to it. Negative results must be recorded as correct inferences can be drawn from these. Again, so what are the examples of negative results? No precipitate is formed, or solution remains colorless, or something like no visible change. Okay, even if you literally do the test, you do 5 things and then nothing happened, you must still write no visible change. Okay, so this is part of the test itself. Okay, so again, please, if you take one thing away from this QA portion, is that even if a negative result comes out, you must still write it down. Okay, so number 4, very similar. If you do not observe any change, you must say no visible change or no visible reaction. Okay, do not leave a blank space. If not, they will just minus 1 mark. Okay, so lastly, this is your observations checklist. This one also very, very important. Do put a star. These are the 5 exact things you should be looking for to score your marks. Okay, so these are 5 things that they are marking for. Number 1, effervescence. Is there effervescence? If yes, what test do you do and what gas do you form? Okay, so literally any effervescence that you see must test. Okay, don't make this careless mistake. You must test for literally any effervescence. Okay, then the next thing they're looking for is your change in color. So when you write change in color, you must write the before, you must write the after. Okay, so for example, solution turns from colorless to blue. This is a good example. So again, you must write before, you must write after. Okay, third one, if there's a precipitate, right, does the precipitate dissolve? Okay, for example, the white PPT dissolves. Okay, next one, what's the difference in excess? Okay, if the question asks you to add in excess, right, you must purposely state when added in excess, blah 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 happens. What if we accidentally do the test wrongly and get a negative result? Then nothing I can do for you. Hi Chia, why do we acidify with dilute nitric acid before adding the silver nitrate? That one I'll talk about later. How do we know which gas test to do? That one's a good question, very good question. How do you know what gas test to do? You need to think about what kind of reaction is happening. For example, if the test was magnesium plus H2SO4. Okay, what kind of reaction is this? This is your metal plus acid reaction. Okay, so you must use your own logic and your own knowledge to remember that this normally forms a salt and water. Right, salt plus water. So, sorry, not salt plus water, salt plus hydrogen. So logically, you can infer, right, that if I'm doing a metal plus acid test, hydrogen is probably going to be formed. So this is one of those things that you just need to use your own knowledge so that you can be kind of one step ahead. Can I fake the gas test results or is it must carry out? I will recommend you to carry out. Yeah, you must, it's like an educated guess. Okay, so let's look at some of the good observation writing. Here, for part A, you see they say white precipitate is formed. And then when you add it in excess, it dissolves in excess, forming a colorless solution. Okay, very good observation writing. Okay, similarly over here, it's soluble in excess, blah, 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 blah. Okay, so if a test has 2 parts, you need to make sure that you write the observation next to the part that achieved the observation. Okay, so like this, you should write at A and then at B. But then what happens if they don't tell you what the salt is, like unknown salt K? Then you just need to try. Okay, then the next part over here, for example, if you have gas, colors and odorless gas produced, gas formed in lime water, identity of gas is carbon dioxide. Okay, new part for those who go write who did your QA, you got the correct gas, and then suddenly you minus 1 mark for no reason. It's because you probably didn't state what's the identity of the gas. Okay, the identity of the gas, you must tell them what the identity of the gas is. Even if you get the correct observations, if you don't write down the identity, you don't get any marks. Okay, last part for QA, for the blur kings and queens. This one is for those people who think that they or thought they were doing quite well in the QA part, then suddenly out of 8 marks you get 2. Okay, so these are all the common mistakes, okay, all compiled into one. All the common mistakes you can read through. Don't use the term milky, don't use cloudy, don't say clear solution. Okay, you cannot say clear solution, you must say colorless solution. Okay, don't say transparent solution, you must say colorless solution. Okay, don't use the phrase solution turns into a precipitate. Okay, that makes no sense. You must say that the precipitate is formed. Is writing PPT okay? Only okay. Yeah, you can write PPT in QA. Okay, so these are all the miscellaneous tips for those blur kings and queens out there. Yeah. Okay, let's not waste any more time. Let's look at your QA past year paper. This is VS, Victoria School 2024 paper. Okay, over here I've compiled all the different observations that occur. So I need you guys to take 1, 2, 3, 4, 5. Okay, this one, question 5, there's no picture here. There's no picture here because there was no change. So what are you gonna write if there's no change? No change. Okay, so over here, please look at the images. I'll give you guys, using the tips that we have just learned, all these tips, right? I need you guys to try and solve test 1 to test 5. Okay, I'll give you guys 5 minutes to try this while I answer questions. Yeah, correct. No visible reaction. Good. Sorry, can I ask if the QA sheet will be given? Yes, the QA sheet will be given. Okay, let's look at this. Now already 5:33. Let's go through. First of all, the thing like I mentioned just now, right? Before you start, you should look at each of the different tests and then note down whether is it a cation test, is it an anion test. Okay, so first of all, what I want to do is look through each one of these and then note down whether it's cation or anion. Here, aqueous ammonia is confirmed a cation test. Okay, again, cation test is either sodium hydroxide or aqueous ammonia. Okay, then for 2, aqueous sodium hydroxide, again, this is a cation test. Specifically here, right, they said no further change is observed. This means that you are in excess. Okay, same thing over here, no further change occurs in excess. So very, very standard question a lot of people ask me is, what is, how can I tell whether it's in excess or not in excess? Okay, if they told you drop wise, if they told you drop by drop, this is not in excess. If they specifically say no further change occurs, if they specifically say in excess, then it's in excess. Okay, for part 3, aqueous silver nitrate, this one is part of your anion test. This one, sodium hydroxide, again, this is your cation test. Aluminium foil, this one is part of your anion test. And then lastly, barium nitrate is part of your anion test as well. Okay, so this is your answers over here. How about slowly? Slowly, if they said slowly, until no further change, is excess. If they just said slowly, then it's not, then it's normal. Yeah, the slowly doesn't do anything, doesn't change anything. What happened to the mic? Can you guys hear me? What does the not in excess mean? Okay, in the QA sheet, there's 2 different observations, right? It's the in excess versus normal. So yeah, it doesn't matter. I mean, it doesn't matter, but that's exactly what I mean. When I mean not in excess, I mean the first one. Okay, so over here, let's look at the observations now. Okay, let's look at the observations. Here, there is light blue precipitate formed over here. You see over here, there is this translucent looking thing. Okay, so very important, the difference between a solution and a precipitate is that what the hack that I always use and give my students to use, right, is you just take the test tube, you lift it against the light. Okay, there's probably light on top. You just look through the light. If the light can pass through, that means it's a solution. If the light cannot pass through, it's a precipitate. Okay, so in this case, light blue precipitate formed. Okay, and then when you add in excess, when added in excess, blue precipitate dissolves to form deep blue solution. Can I say colorless solution turn dark blue? No, because here the specific observation that you must say is that the precipitate dissolved. Is that not dark blue precipitate? Okay, good question. If it looks like a dark blue precipitate, right, then you must go check whether your syllabus or your QA sheet even has a dark blue precipitate, right? If it doesn't, then logically it's not. Can say dark blue or must say deep blue. Can say deep dark blue also can. Can you repeat the difference between precipitate and solution? Solution, the light can go through. Precipitate, light cannot go through. So solution is kind of transparent. Precipitate is opaque. Basically, that's the idea. Dark blue can, yeah. You can write PPT. For the observation, do we just copy? Basically, yeah. Okay, let's move on to the next part. Sodium hydroxide here. Light blue PPT again. In this case, your light blue PPT insoluble in excess. Okay, what you notice also here, right, is that there's some black stuff. So you must say that the light blue PPT turns black. And then the one extra thing over here is this litmus paper blue. Okay, so take note, please star this down. The only gas in your whole syllabus that turns red litmus paper blue is ammonia. Okay, turns red litmus paper to blue. It's legit the only gas in the whole syllabus that does this. Okay, so if you ever see this happening, you must know that it's ammonia gas. Okay, so over here, you must state that effervescence is observed. Gas released turns red litmus paper blue. Why got black PPT? This one is just part of this question. It's a bit weird. Okay, it's because you warm the mixture gently, after that suddenly there's some black stuff lah. So if I see hydrogen peroxide, immediately test for oxygen. Yeah, good question. Why litmus paper need to be damp? Turns black is after heating. Yeah, so the way I structured it was like this was this, and then this is this, right? So the first part is the first test, and then the first observation, second observation is the second test. How to know to test for ammonia? In this case, okay, for this question specifically, you'll be able to smell it. Do we need to say pungent gas? Yes, so the next part of this, you need to add that gas produced is NH3. Hello, you spelled effervescence wrong. Oh, my bad. Effervescence with a C. Okay, question test 3. To 1 cm depth of X in a test tube, add aqueous silver nitrate. What you'll notice here is that because it's blue, right? It started off as blue, and then now when you add silver nitrate, it's still blue. So what you need to say is no observable change. Do we need to say upon warming? No, not necessarily, because if you rotate here, you're basically saying that, oh, after this test, I got this result. For black color, how do you know it's solution of PPT? Okay, this one's a little bit hard to answer right now because you cannot see it in real life. But in the actual exam, what you should do is put it up against the light. Okay, if the light can travel through, it means that it's a solution. If the light cannot travel through, then it's a precipitate. So does that mean no chloride and no iodide anion present? Yes, correct. Very good. This means that it's a negative test for the anion test. Okay, so no chlorine and no iodine is present. Okay, next part. Cation test. This one same thing. Blue PPT formed. This one no further change again, so it's in excess. So blue PPT formed. which is insoluble in excess. Okay, when you add in the aluminium foil and warm gently, effervescence observed. Gas released. Turned red litmus paper blue. Gas is NH3. For test 3, isn't the solution turns light blue? Okay, this one I understand the confusion because you're not seeing it in real life, but the actual X itself is already blue. So when you just see it blue again, it means no observable change. Okay, sorry for the inconvenience because you cannot actually see it in real life. If the solution becomes cloudy, does it mean there's white precipitate formed? Yes. Hi, when do I say PPT or solid or deposit? Solid and deposit can be used interchangeably. Is when it settles at the bottom, like the solid settles at the bottom. Do we have to identify? I thought they just asked for observable change. In this case, whenever there's a gas test, you must identify to get full marks. Do we need? Oh yeah, sorry, I missed out the black one. Yeah, so you must also say blue PPT turn black. So this is upon the aluminium. So then what's that black stuff? That one is totally different. Yeah, I know. I understand there's the random black stuff. That one came because of the aluminium foil. Sorry, that one I missed out. I just own self careless. Aluminium is added to test for nitrate. Correct. So the next part is your the next part here. This is your sulfate ion test. In this case, there will be no observable changes. Okay, so remember your barium nitrate is an anion test for your sulfate anion. So if there's no observable changes, this is a negative result for it. So meaning that there is no sulfate ion. Okay, so what's the next part? I want you guys to try using all of these observations. Please try the next 3 parts. I'll give you guys 3 minutes. Figure out what is the cation in A. So okay, A basically means the starting point lah. So yeah, these are all samples of A. And then figure out what is the cation and anion in salt B. Okay, so if you are damn confused, you don't know what on earth is happening, right? Look and read this paragraph here. The paragraphs in front of the QA, right, is legit damn important. A lot of people forget or lazy to read. Okay, so please read this one, it's damn important. Yeah, actually I'll give you guys about 5 minutes. I'll give you guys until 5:50, then we'll go through this. Okay, I'm back. Sorry, the thing glitch. Okay, the salt B is basically okay. Sorry, okay, salt B here, it was at the front. B is just kind of impurity. So basically, there's one other cation, one other anion that is within the solution. So you need to figure out what are these two anions and cations. Okay, so it doesn't really matter what salt B is. It's just that it's there. There you go. Sorry, my mic off. I was trying to fix my mic. It's damn embarrassing to be on camera trying to fix my mic. Yeah, don't expose me. Okay, 2 more minutes, I'll go through the QA deduction part. I didn't leave, no, see, B is just that. Okay, basically the solution has some A and some B. Okay, so the cation and anions in B are part of the mixture that you're using. Okay, so it doesn't really matter in this case what B is. You're just testing for, you're just looking for, through these results, what is the other cation and anion that you can identify. By the way, the idea of salt B is on, like, the is not very important in this case. Thank you, Evangeline. Yeah, correct. Acidify with nitric acid is correct to get rid of the impurities. Okay, because there'll be other anions that it may react with. Okay, guys. For part 2, deduce the identity of the cation and anion present. This one you must, first of all, they ask you to describe the observation which allowed you to make the deduction. Okay, so we want to specify which test it is. Okay, so first of all, your cation, which is the other cation, which is not your copper. So this one is copper, by the way, because this one is quite obvious, it's just blue. So you should know that it's copper. The other cation available is your NH4+, your ammonium. Okay, why? Because in test 2, ammonia gas was produced after heating with aqueous sodium hydroxide. Okay, and then your anion is your nitrate, NO3 minus. This one, it comes from your test 4, which was ammonia gas produced after heating with aluminium and sodium hydroxide. Can so please copy this down first. It's copper, NH4 and NO3 minus. Okay, if you got correct, can you put a thumbs up in the chat or like a heart in the chat, or just put some more emoji at the side? Can I write the name instead of the formula? Okay, good question. Yes, you can. Okay, so if they say deduce, if they say state the identity, you can write either the name or the formula. If they specifically say name then you must write the name. Okay, good job, guys. Can state the name of, yeah, can state. Okay, good. Okay, the last part I want you guys, I want to go through. Now it's almost 6 p.m. already. I I just want to specify 2 types of titration that I personally think and I predict will come out. Okay, so if you're going to do any practice on these ones, please practice these 2. Okay, there are 4 types of 5 types of titration, but specifically this year I think either thermometric or back titration is going to come out. Okay, so thermometric is measuring the temperature change. Back titration is basically you measure A by adding excess B and then titrating B with another substance. Okay, meaning like I figure out how much A I use by measuring how much B was used. Okay, so specifically these 2 are very important. Okay, again, if you are quite solid, you can go memorize the indicators, but not 100% necessary. Okay, very rarely do they test. Okay, for a titration table, this is just an example. For the mass reading table, this is an example. And yeah, okay, so this is an example of a titration question. Okay, so over here, this is a titration question that I've identified. If you guys want, you guys have time, please try the calculations here. Okay, I've already given you guys all the necessary things to note. This is a thermometric titration. Okay, so if you see a exothermic, if you see temperature change, that is your thermometric titration. Okay, so in this example, I've given you guys the table with all the values. I've given you guys the graph. I've actually drawn out the graph for you guys. Okay, so what you guys need to do, I want you guys to try in your own time, is your calculations. Okay, part C, part D, and all the way until part E. Okay, so all of these are very important. Again, for me personally, what is going to come out, I believe, is either thermometric titration or back titration. Okay, so again, please highlight these ones. When do we use the mass reading table? Is when you have to measure a certain amount of mass. Okay, so for this one, let's take 1 or 2 minutes and try C. Okay, so the issue over here that a lot of you guys have with thermometric titration is the graph part. Okay, over here, these are the values that you're supposed to get. I already written it down for you guys. What you need to plot is your temperature rise against your volume of Q. So the idea here is the more volume of Q you add, what does the temperature change? How does the temperature change? Okay, so in this case, you want to plot it on the graph like this, and then it will nice intersect over here. Okay, so over here, your temperature rise, the question here is asking you volume of Q, read the volume of Q and the temperature rise when the 2 lines intersect. Okay, so here your 2 lines intersect around here, which will give me 7.1 and then 25 cm cube. Okay, so that's how you draw the graph. Okay, so the graph is going to go up and down, and then you want to draw 2 intersecting lines. Okay, so volume of Q is 25 cm cube, temperature rise is 7.1 degrees. How do you know which point to intersect? Okay, when if you imagine this red stuff was not there, right, it'll be quite obvious because the graph will look like, you imagine all the x's, you just see where the x, the highest x is, it should intersect around there. Yeah, I don't need to pass through origin, yeah, correct. But in this case, I just did it very quickly. What is back titration? Okay, back titration, yes, like Zebra said, back titration actually, if it comes out right, they will tell you exactly what to do. Okay, so it's not that scary one. Okay, but just be prepared for it. Back titration just has to do with a lot of calculations. Okay, so again, these are the different type of titrations. If you're going to focus on 1 or 2, focus on your thermometric, focus on your back titration. Your school confirm gave you some questions that you can try. And yeah, is it true your axis does not have to start from 0? Okay, it's definitely preferable to start from 0, but not necessarily that you have to start from 0. Explain back titration. Okay, the basic idea of back titration is that let's say I have A, and then I react it with B. Okay, so I have an unknown amount of A, number of moles, and then I'll have a known amount of B, let's say 1 mole. Okay, then after this reaction finish, right, I take the B that is left over, so there's leftover B, and after that I go test it again with something else. Let's say I react it with C. Okay, so from there I go calculate. Maybe I calculate that there was 0.5 moles left of B. Okay, that means in this reaction at the start, 0.5 moles of B was used. Okay, does it make sense? Because 1 mole became 0.5. So this is the idea, the simple idea of a back titration. Okay, so we don't have enough time today to cover an actual question, but this is the idea so that you guys don't get confused. Can you draw the arrow for the axis out of the graph paper but keep the values in the graph? As long as the values is in the graph paper, it's fine. I know what you mean, like over here, if you have the arrow like outside here, yeah, it's fine. Okay, predict what coming out tomorrow. Okay, again, don't quote me, but you just look at these two highlighted stuff. How to find leftover? The question will guide you. Okay, so don't be too scared. Just be prepared for this to come out. Okay, because the question will guide you such that you can just quickly do. Okay, but we don't have enough time to cover more concept stuff. Do one question of back titration. Later, I'll send one to the group. The graph must start from 0, not necessarily in every single case, but it's always better to start from 0 lah. Can you extrapolate? What do you mean by extrapolate? Which one do you want me to the graph here? For planning, how do we know which indicators to use? It depends on which question. It's hard lah. It just depends on which question. I can't really answer that. Okay. Last minute tips. Okay, last minute tips is look over here, your QA, where is it? Okay, for planning your errors and precautions, I just want to mention one more thing. This is page 5 before we end. When you think of your errors and precautions, okay, because sometimes you just want to add in some errors and precautions to make sure you get the full marks. You want to think of SI units to figure out what kind of errors and precautions you can get. Okay, for example, you think of meters, time, which is seconds, and length. Okay, so over here, your titration, one of the error, it could be misjudging the endpoint, leading to inaccurate volume readings. So again, this is just a way of thinking such that you can think of some errors and precautions. So you just think of what units do you use, and then therefore, from there, what kind of precautions can come when I measure these units, when I try and calculate these units. Okay, so that's our tip for today. How do you know when you need to write solution remain colorless, no visible change, no PPT? Okay, if nothing happens, then you must say no visible change, no observable change. They can ask you to prepare sorts in planning. Yes, correct. Must give prediction for planning? No, you don't have to give prediction. Someone knocking at the door. Yeah, I know. I heard also. Okay. 2 more minutes. I will answer a few more questions. If not, then that is about it. Please stay a little bit so you guys can hear all the questions. How do you know when to use 2 lines or 1 line? If the graph looks like this, for example, like this, right? If the graph looks like this, then obviously it's 1 line. Okay? But if the graph looks like something weird like this, right? Go up to the top and bottom, and then the question asks you to draw 2 lines, then you draw 2 lines. Thank you, Cher. I understand it better. No problem. Must give assumption for planning. Like can just go through question 3 of QA one more time. Okay, I'll do it just for you. Which one? Question 3 over here. Here, this one. Do we need to memorize salt prep and rate of reaction? Yes. To prepare for planning, should we just go through our old worksheets? Yes, do that. How do you know if it's curve or line? That is based on the question. Is if it's very obviously like this. Okay, in O levels it will be very obvious if it's curve or if it's straight. Okay, so if it's just generally looks like a straight line, then it's can. But if it's very obviously a curve, it will be very obviously a curve. It will look something like this. Okay, so don't be too scared for this. Common mistakes for planning is over here. Let me see. This one here, under your general tips. Okay, please read through this. Ammonia produces effervescence. Yes, and all gases produce effervescence. How to draw best fit? When you're doing best fit, right? Let's say I have 5 points. I want to make sure that there's an equal number of points above and below my best fit line. Okay, so for example, I can draw something like this, right? So you can see there's 2 points above my best fit. There's 2 points below my best fit. Whack, I've already predicted the titrations. Okay, so best fit line, the number of points above must be equal to the number of points below. Yeah, if you want, you can DM me questions, but I cannot promise you that I'll reply before tomorrow because there's a lot of questions. Hi, do we need to memorize separation technique step? Yes. Do we always have to give precaution for planning? Yes. How do you make sure you don't miss out any points on planning? A, C, I, D, S. And just think about it logically. Would they ask you to prepare a salt in practical? Yes, it can come out even for planning also. Okay, the video I will leave up for a little bit. Thank you all for joining. Any questions? If you guys have questions, please text me. If you guys want, again, like I said, a lot of you guys have reached out. I'll reply to you guys soon. For the bootcamp, it will be 4 intensive sessions, full year's worth of notes and worksheets, the full year's cheat sheet and summaries, and we will do a quick study plan, 4-week study plan, as well as a strategy call. Okay, so I'll go through your prelim paper with you, and we'll note down which topics you need to focus on, which topics you can chill a bit on, and yeah, specifically what's the priority, 24/7 WhatsApp support. These are our 4 bootcamp sessions. Number 1, your structure and bonding. Importantly, this will teach you how to not make a dot and cross mistake ever again, your atomic structure stuff, all the mole calculations. Okay, so each one of the sessions is about, by right it should be 2 hours long, but it will confirm extend to 3 hours honestly, because there'll be a lot of questions. Okay. Then for organic chem is all the organic reactions and all the identification tests and your drawing. And lastly is your energetics and rate, which is quite a big portion of your paper lah. Okay, so the sessions are on Sunday 4 to 6. Everyone should be free, as well as a bonus MCQ mastery session, which is free of charge. Okay, so again, this is only for 8 students. If you want, please reach out now. The QR code is on the right side. Again, I can only take in 8 students. I'm so sorry for those who are not fast enough. I cannot take you because I can only ensure that these 8 kids will be taken care of very well. Last year, our improvement was +4 grade jump. And yeah, again, this is the price for the bootcamp for the month. Everything included with all these free stuff. Okay, so again, it's limited to 8 students. If you want, can scan the QR code here. I'll just leave it on the screen for a while. Thank you guys for joining again. All the best for tomorrow's practical. Again, please text me if you have questions. Please text me if you've got questions. I will try to reply to you guys as soon as possible. Can? Okay, thanks for joining, guys. You guys can slowly leave now. Bye-bye. Okay, I'll reply some questions in the chat. But if you want, you guys can leave. I will close it in a bit. Yeah, 40 for 40. 40 out of 40 for prep. Thanks, guys. Bye-bye. No problem. Bye-bye. If I don't get A1, got money back guarantee. Sadly, no. It's Singtel Dash, you're the GOAT. Actually, you're the GOAT. Okay, thanks guys. Bye-bye. Bye bye, you guys can leave. No worries, Erin. No worries, Race. Okay, Vina, you can watch the clip will be up for a while, like maybe 1 hour, 2 hours. Sure, can send precaution and error page. It's on the worksheet. If no A1 got refunds, sadly I cannot. Slay, we all get A1. Yes, eventually everyone get A1. Varia, thank you. No worries, Varia. Can go through the positions. That one is just memory work. Predict planning, please, is the 4 ones that I've chosen in the worksheet. You can see that page. Yoha, thank you, Chen. No worries. Okay. No worries, Dino. No, you are the good Dino. Okay. Thank you guys again. Please text me if you need. If any questions for the bootcamp, let me know. No worries, Yoya. Always 3SF for your answers, yeah. Tables for titration use 2DP. Lifesaver TTT. No worries. Okay, bye bye. Bye guys. Okay, I'm gonna end the stream. Bye bye. Bye bye. Thanks for coming. Bye bye. Which one do you think in your mind, in your soul, in your gut will come out? That one I cannot say. That one's for my tuition kids. Bye guys. How much the bootcamp is total with everything included $720. It might seem very expensive to you guys, but I promise you tell your parents they'll be pleasantly surprised. No worries, Evangeline.